Okay, welcome everyone to the Minds, Technology, and Society seminar. Thanks again to the Glushko and Samuelson Foundations for funding. Okay, so today our speaker is Simon DeDeo from Carnegie Mellon and the Santa Fe Institute. Simon is an assistant professor of social and decision sciences there, and also external faculty at the Santa Fe Institute. All his degrees are in physics, I believe.
That's right.
And then he spent some time at the Santa Fe Institute, and through the mutagenic properties of that place, gradually transformed into some sort of hybrid cognitive scientist, data scientist, madman of social computations. I'm really excited to have Simon here to give this talk on the data science of culture from the French Revolution to string theory. Take it away.
Thank you very much. So it's a real pleasure to be here. And having been out to UC Merced before, you guys have a really fantastic program here. The grad students are really lucky to be here, and you guys are also doing some really fantastic projects. It seems like a really exciting place to be. So it's an honor to be here. And we have some time. I'm not going to fill up all the time with my research. I'm more interested in how much you hate my research. So, and we are being videotaped, but they can't see you. They can only see me sweating. So you should ask as many questions as you like, and I'm happy if I only get through half an hour of my speaking. The other thing I'll say before I begin is that I'm going to talk about a field that is still in the process of coming into being. It's a field where people in the data sciences, people with a machine learning or computer science focus, people with a social science, political science focus, and then people working in what we call the humanities, so people working in history, in English literature, in philosophy, are increasingly coming together to do. So I guess that's sort of cognitive science too, right? So that's perfect, right? But it's an opportunity to study something we have not been able to study ever before, at least in the quantitative sciences. And that's not what people do in the lab, it's not what people do in an MRI, but it's what people do when they do the things in life that matter to them the most, the things that they invest their intellectual life, their perhaps entire intellectual life to doing. In the case of the French Revolution, as we'll see, it's things that people not only devote their lives to, but are willing to give up their lives for. We're able to study this because now we have access to archives of human behavior that are not just broad in terms of the number of people. Actually, all the work that I'll show you is not, it's not a study of 3 billion people. It's not a study of 100 million people. It's the study of thousands of people. But what we have and that we don't have, let's say, in Facebook is we have depth. And the archives I'll talk to you about can range from a few years to decades to hundreds of years. So we're able to study the kind of behavior that, in the end, we get into this business to understand in a very new way. And I'll introduce some tools, so if you don't like the things I study, study your own. Because the tools that we use, that we've stumbled upon, are incredibly effective and work incredibly well. They work better than they should. And they also enable us now to compare systems that we thought previously to be incomparable. Most of the people, at least some of the people I study are dead. So we really can't put them in an MRI. But fundamentally, and this is still true, and it's going to be true until Elon Musk builds the Neuralace, if I want to couple my brain to your brain, if I want to get the contents of my brain into your brain, there's basically only a few ways to do it, and the most important way is we talk to each other or we write to each other. There are other ways, like I'm gesticulating here, but like the primary information channel is my voice. And the primary information channel for you to, talk about my talk is for you to talk about my talk. You can, pose in the way that looks like you're bored or excited. But this is fundamentally what we do, okay? So if you want to study social cognition currently, you have to look at speech. So I'm going to study systems where we have records of people's words. In one case, they're words that they've written. In another case, they're words that have been transcribed by somebody else. One of the fundamental questions, okay, so you get to splash around in the pool, but where are you swimming? One of the fundamental questions that I and my lab are interested in is this. Where do new things come from? And what do we do when we get them? This is a question that's preoccupied people who study political science, who study the evolution of culture, who study intellectual life. Thomas Carlyle, one of the famous conservatives who hated the French Revolution, put it this way: originality is a thing we constantly clamor for and constantly quarrel with. Newness is something we both desire and dislike. It's something we both seek out and reward, but it's also something we reject. It's a good that I don't think can be measured in any kind of utility-based theory, although I won't quarrel with the economists on that one. I'm going to teach you a tool to study and to answer, or try to answer, this fundamental question. It's a tool that comes out of something called information theory. So I'm going to give you just a quick 5-minute crash course in information theory. Who here has heard the phrase information theory? Okay, who here thinks they know what information theory is? Okay, you're up, Paul. So information is a word we like to use. Instead of saying I'm correlated with you, I can say I have information processed to you, right? This is a word that we fundamentally find attractive. I'm going to tell you what it is, or at least the one way we know how to quantify it. I'm going to begin with this game of 20 questions. So do people know this game, 20 questions? Sometimes called animal, vegetable, mineral. So the way it works is that, okay, usually it's a game you play with your child because it's pretty boring. There's a child and there's a parent. The parent has something in mind. The child is asking questions to the parent to figure out what's in the parent's mind. The only rule is the questions have to be yes/no questions. So I'll play this game with you, Paul, really briefly. Okay, so you be the child. Okay, so I have something in mind. All right, go.
Is it alive?
Yes.
Is it a human being?
No.
Is it an animal?
Yes. Human beings are animals.
It's true, but it's still a valid question.
See, so that's where we differ from computers. Is now the protocols are broken. So I always think of the same thing. Somebody got it once. I won't tell you what it is in case I have to give this talk again. So Paul asked, okay, is it a human being?
Is it a red panda?
See, okay, bad question, right? Because unless he has a really strong belief of my obsession with pandas, in fact, you should have said, is it a panda? This game was actually a game show. It's briefly a game show on Polish communist television. And that's the reason why communism died. So what they would do is they'd get like the plumbers union and they'd play 20 questions. And so the game had to be canceled famously because the mathematicians union came up. And they said, okay, comrade, does the first letter of the word fall in the first half of the alphabet or the second half of the alphabet? And they said, okay, first half, right? Does it fall in the first half of the first half or the second half of the first half, right? And if you have 20 questions, you can actually split down, if you do this correctly, you can actually split down to a million possible things, and nobody has a vocabulary when approaching that. So you're gonna win that game. You might notice that there's more words in the first half of the alphabet than the second, so maybe you don't want to split exactly there, right? Maybe you want to split a little bit to the left, right? So you have equal populations on both sides. What that's driving at is that there are better and worse ways to play this game. There are ways to play this game so it gets over as quickly as possible. So let me give you an example here. Let's say you're playing 20 questions against your father or parental figure 1, right? And your father has this distribution, and we're going to play the game. There's only 3 things, because I won't write this all out. It's distribution, and so half the time he's thinking about car, a quarter of the time tree, and a quarter of the time bird, right? So if you want to get this game over as quickly as possible, what is the question you should ask first?
Is it a card?
Yes. Okay. Everybody gets this except the University of Colorado, so they didn't get this. Yeah, is it a card? Because half the time the game is over in one question. You're done, right? So the other half the time, no. Okay, so now you actually have to ask another question. There's a couple different ones you can ask, but one is, okay, is it a bird? And then, is it a bird? Yes or no? Now you're done. So on average, right, this game is over, okay, in 1.5 questions, right? So half the time you get 1, and half the time you get 2 yes/no questions. So on average, okay, that's how many yes/no questions you need to ask, right? So you guys came up with this optimal tree. Coming up with optimal trees for longer and longer lists is not entirely trivial. But in fact, as Claude Shannon proved in 1945, you can actually figure out, given just this distribution here, how many yes/no questions you need on average in the optimal case, and it's this equation here, entropy. It's called entropy by the physicists, it's called information by the information theorists. All you need to do is figure out or know the probabilities of the different options, right? And without even constructing the tree, you plug in here pi log base 2 pi, and it's log base 2 because you have yes/no questions. If you are able to ask questions with 3 possible answers, you use log base 3, right? Pi log pi, and you sum over all the possible options, and then you forget and you put the minus sign in so it's positive. So what I want you to think about here is information is essentially a two-way process. It's a process of interrogation, and the amount of information in Paul's head is the average number of yes/no questions I need to ask in order to figure out what he's thinking about at any point in time. Okay. You can think of that tree as an encoding. It's a theory I have about Paul. It's a theory I have about the way Paul's mind works. Let's imagine that I have a theory about how somebody works, and I turn out to be wrong. And so here's a possibility, right? Let's imagine I built this question tree, I built this encoding, right? I have a theory of my father, or parental figure 1, right? And I use it on my mother, okay? So, I'm expecting my father, and I get my mother. It's a Freudian thing. And, okay, so your father's an Uber driver, so he was related, he was sort of weighted here, and your mother is like a theoretical ecologist, so she's weighted towards tree. So half the time she's thinking about tree, and you're like, whatever, I'm going to use my father encoding, and it's no longer the optimal encoding, right? The way you should split is it a tree, yes or no? But in fact, you're stuck with you're stuck with the theory that your mom is like your dad, right? And now, even though, okay, there's an optimal number of yes/no questions for mom, just as there was for dad, if you use your dad theory on your mom, okay, it's inefficient. It's inefficient by 1/4 of a question. We can also measure this without doing any of that. We can measure this. It's called Colback Hyperdivergence, okay? Colback Hyperdivergence is just getting this 1/4 out of this problem here. You don't have to construct the 2 trees. All you do is plug in pi is the mom and qi is dad. And you can think of Colback Hyperdivergence as measuring how many extra yes/no questions you will need if you think it's Q, if you have theory Q about the universe or your mom or the person in front of you, and it's actually P. Okay? That is the only mathematical tool you need to do everything else in this talk. Okay? The story, I would argue, about how culture works, how people interact with each other, is pattern making and pattern breaking. Building theories of the world and discovering that they're wrong. I understand you had Andy Clark here, right? So when I saw Andy Clark, I was like, I don't know, you're Hume and I'm like the guy who needs Hume, right? So this is not to me, this is a story about novelty. It's a story about creativity. It's how we notice when something new happens. There is a very popular story about newness. There's a very popular story about innovation. Okay, that I think is wrong, or I would argue that you shouldn't do. And one of the reasons you shouldn't do it is because everybody's doing it. So not only is it wrong, but you'll be crowded out. Okay, and that standard theory of innovation is what I call the Lego brick model. Okay, in the Lego brick model, the theory is that basically all ideas or all things that we do are actually kind of combinations of atomic units of idea substance. And we glue them together in different ways, and what it means to be innovative is just to glue together 2 Lego bricks that no one's glued together before. Okay? It's sort of a discretized digital understanding of culture. This is a theory. We have no evidence for it. It's incredibly compelling to people. If you stop someone on the street and force them to give you some kind of sort of abstract account of what creativity is, it's probably going to sound like the Lego brick theory. It's, in some cases, there's this bizarre feedback loop, so people think this is what innovation is, and so they hire people to do exactly this. A friend of mine who does digital humanities, Graham Sachs, so Graham also worked as a script writer, so if you want to pitch a script to Hollywood, right, it's like A plus B, right? Abraham Lincoln and zombies, right? And so they have a Lego brick model of innovation, no one's done Abraham Lincoln and zombies, so let's do that, that's how we innovate, right? I don't think this is true, except in some very limited circumstances. You might say this is maybe what Kuhn meant by normal science, right? You just take a bunch of concepts that people already have, I know. So I don't know. This is what Mark Hauser used to do, right? Oh, you did it on babies. I'll do it on monkeys, right? We saw how that ended. So I think this is wrong. I think this is not true. People think about this. This is the way they describe it, right? So. Why is the iPhone so innovative? Because no one glued a camera onto a telephone before. What was the Higgs mechanism, the thing that won these Nobel Prizes? Oh, you just glue together quantum field theory and condensed matter, and Graham didn't write this, thank God. when we come to study innovation and novelty and creativity in culture, we just inherit this Lego brick model. Okay, and so some colleagues, I was up at the San Fe Institute recently, were talking about study the patent system, right? So if there's going to be novelty anywhere, it's going to be in the one case where like you're legally required to be novel or creative, right? And what we do is what people tend to do is they look at this patent, right, and they say, okay, look, right, somebody's categorized it. So this is a patent here. Actually, this is a story about a friend of mine whose wife is sick. And this is like the patent that is underlying the medication that she's currently on. So it's kind of a emotional thing. Here are the categories that this patent falls under, and so you might say, okay, what's innovative is like, oh, a combination of patent categories that have never occurred before. Maybe that's innovative. Or like, this patent cites other patents, so maybe like what's innovative is like the combination of different citations that haven't been combined before. Or maybe like, okay, you go outwards into the scientific literature. So these kind of structural, discrete models of creativity are everywhere. I'm going to show you, instead of going to this combinatorial model, we're going to go to this Bayesian pattern breaking model. So I'm going to, instead of trying to say, okay, and I'll begin with science and we'll end with the French Revolution, so the opposite direction of history, go backwards in time. I'm going to talk about innovation in science, and instead of saying, okay, we're going to decompose every scientific paper into a set of atomic units and then figure out, okay, combinations that haven't appeared before. Instead, what we're going to do is we're going to convert each scientific paper into a probability distribution over the patterns contained within it. And I'll tell you a little bit how that works. But let me first introduce the data. Is there anybody here who spent time in physics? Paul, right? Computer science? Right, so the preprint server is this wonderful thing. It was kicked off by Paul Ginsparg years and years ago when the internet was just building up and it was spreading around. And it's essentially open science before anybody had a pretentious term for it. Everybody in physics, or at least in certain fields of physics, including astronomy, which is what I used to be in, and theoretical physics, people publish in journals, but the first place you always put your paper is you submit it to the preprint server, and there's a sort of very mild crank filter to make sure you're not crazy. And the primary crank filter is, did you write it in Microsoft Word? And the next morning it shows up on the preprint server. And when I was a graduate student, if you wanted to like really get up on things and you really wanted to be a real player, every morning it was like your homepage. And then, in my case, when I was a graduate student in Princeton, like you'd actually go and all the faculty would be sitting very solemnly in the coffee room at 10 a.m. and they'd be just complaining about all the crap that their competitors had come up with on the preprint server. This is wonderful because everybody's looking in the same direction. This is the meeting we had every day at Princeton was not the only one. There, in fact, at this point, how many? There's like on the order of 400 of these meetings at physics and astrophysics departments around the United States and beyond. So the case I'm making here, and this is a little bit of a nerd case, right, is that like, this is where physics happens. It doesn't happen in the journals, right? Eventually people go into the journals, it gets peer reviewed, right? But where it comes out first, what the dialogue actually is on this largest scale, right? The maid handing the paper to the mistress, this is where that happens. This is a wonderful phrase, right? The archive is a social cloud chamber. Right? The ideas that pass through physics leave their trail first, right, on this website. So what we're going to do is we're going to take a paper. This is the paper I wrote, but you can't see it because it's too small. We're going to take a paper and we're going to decompose it into a set of patterns. A standard way that people have done this in the past is just word counting, the frequency of words. And this actually can be a very good diagnostic of particularly style, right? So we all have individual patterns of word usage. If you've ever read a paper by somebody who's Russian, you'll notice that they use definite articles in a very strange way. Word patterns are fun. It's an easy place to begin. It's certainly where we all began. But word patterns they're problematic when you're trying to identify not just the words, but the underlying concepts in play. And here's an example. Here are two papers on the physics archive. This is I'm sure, wonderful paper on black holes. This is a paper on physicists who think that they can reverse engineer the stock market, although I guess he's in economics, right? And you'll notice that both of these papers use the word data, but the word data means two entirely different things in these papers, right? Data is not data. In this case here, it's initial conditions. In this case here, it's stuff coming off the stock market wire. So how do we identify, if we can't just count words to see what's in these papers, what can we do? there's a lovely little bit of machine learning that came out in 2005, and that's ancient history by machine learning standards, but the nice thing is it's incredibly clean, and we all use it, so we're all kind of on the same page when we do this work. And it's called topic modeling. So what topic modeling does is it's what we call an unsupervised model, so you don't tell the machine what's in there, right? But what it does is it notices that some words tend to co-occur, right? So we'll notice, for example, and this is this is from our physics work, so you notice that these words here will tend to co-occur, and in fact, if you sort of figure out what this co-occurrence pattern is, you can often interpret it in terms of some kind of underlying physical move or concept. Here's another term here, right? So this is like people who work in quantum gravity, they'll tend to use the word loop and divergence together. You'll notice that both of these groups use space-time, but the algorithm can figure out that when the word space-time appears in the same paper with the word, let's say, invariance, then it should be classified as a pattern of type 1 instead of a pattern of type 2. There's some wonderful things that this enables you to do. Topic models they almost work too well. It's a little spooky. And so one of the things you can do is, for example, look at papers that seem to share patterns, that seem to share some subset of their patterns. And you often find these very strange long-distance links. And so here's just here's two papers here. This first paper is making one kind of physical argument. This other paper here is making a different kind of physical argument in a very different domain. So this one here is string theory. This one here is kind of a really sort of old school classy model of electrodynamics. In fact, the topic model can pick up that these two papers here are sharing a certain underlying set of techniques and concepts. So that's very exciting. It's also exciting, as I'll get to, because in fact, these papers don't cite each other. These papers aren't co-classified. These people don't know each other. So what we're finding here, this machine is able to pick up essential similarities in the work that people are doing that perhaps these people are not even aware of. So what we're going to do with the physics archive, with this set of papers, and we have on the order of 70,000 of them, they're time ordered. What we're going to do is look at the ways in which papers establish patterns and the ways in which those patterns are broken. So what we're going to do is go from paper to paper and say, okay, given, let's say, that I've encountered this paper coming out on the archive, right? I talk about that in my, grouchy faculty meeting, right? Given that I've learned this set of patterns for how physics is done, at least on this day, how surprised am I on Tuesday, right? If I learn what physics is like on Monday and I come in on Tuesday, how surprised am I? In particular, what's the Colback Hyperdivergence? I have one model, and that model is broken. Of course, we can do this on different time scales, right? Not just one paper to the next, but let's say this month to the previous month, this year to the previous year. We call this novelty. The extent to which I don't look like the past. We introduced novelty, in fact, when we were doing a study actually in the history of science, studying Charles Darwin's work, and looking at how Darwin was actually moving through the scientific literature. And one of the things you find is Darwin is actually, at different points in his career, optimizing for surprise. He's picking books that are actually going to break his theory about what science looks like later. Separate story. Well, maybe that's a theory about if you want to be as smart as Darwin. So we did this in a lot of different systems. We had a lot of fun studying novelty, and at some point in time, we did this kind of obvious move, right? This is actually that figure from our French Revolution paper, which I'll talk about later, but it's the same thing. Instead of physics papers, it's speeches about the king, right? And so here are the things in the past, and here's your focal thing, and you want to say how novel, how creative, how new is this object, right? And the thing you do is just say, okay, here's a set of patterns here. Given this set of patterns here, what's the Colback ladder to the probability distribution over patterns here? Call that novelty. So then we said, okay, well, we can just time flip this, right? And we can say not just how new are you compared to the past, but also how new are you compared to the future, right? So what is newness compared to the future mean, right? It's sort of puzzling. We could just do it mathematically, but sort of what does this mean? So if you look different from the past, okay, that's novelty, fine. If you look different from the future, one way to think about this, if you're a faculty member, say you go to your department chair, and your department chair says, Paul, you don't look like the future of this department. This is bad news. You do, but this is bad news. So while going backwards is novelty, going forwards we call it transience. Okay? If you have high novelty to the future, whatever pattern you've introduced fades away very quickly. It disappears. So we now have two things to measure, right? Novelty and transience. So let's put this up on the preprint server. What we're going to do is we're going to take all the papers, right? And we're going to take each paper and look at how novel it is compared to, I think in this case, 6 months before. And we play with the time, so let's talk a little bit about that. Look at how novel this paper is compared to what comes 6 months before, and how transient is this paper compared to what comes 6 months afterwards. Here's the graph. Each of those dots is a paper, right? So, and the x-axis here is novelty, surprise, or Colback Hyperdivergence given the past. The y-axis is transient, surprise, given the future. We did, right, this is the joke, we did some really hardcore statistics, right, on this, and what do you notice, right, that novelty and transience strongly covary, right? So you say it's like the first law of basically any cultural process that we see, right? What is new is quickly forgotten, right? If you're high on this axis, if you've done something that no one's done before, there's probably a reason, right? It's probably a bad idea, right? What hasn't been seen before won't be seen much again. You mentioned Thomas Carlyle. Here's the sort of philosophical father of the American Revolution who was trying to convince people that don't worry, we can just have one and we'll quit. People are not so easily got out of their old forms, right, as some are apt to suggest. So, if that's true, right, if we just reject things that are new, where does change come from? And, you know, you guys are no fools, right, because that's a pretty good fit, but it's not a perfect fit, right? So look at these guys here, right? These are papers that are novel compared to the past, but don't disappear as fast as they ought to. They don't fade out as quickly as they ought to. And then you say, okay, we called this the distance from the best fit line to the point, right? We called this gap here resonance. If you look at these papers in this resonant quadrant, right? High novelty, low transience, off the axis, it turns out that these papers contain some of the most celebrated bits of, in this case, string theory over the last 15 years. Right? One way to look at it here is to say, okay, look, take the top half of the cited papers and the bottom half of the cited papers, right? So, okay, you have a paper, is it below median or above median citations? And look at the difference in surprise. So, how surprising are the low citation papers? How surprising are the high citation papers? And take the difference. So, looking backwards, what you find is that highly cited papers are more novel than low cited papers, right? If you want to do something that gets highly cited, if you want to do something that has an impact on the field, you do have to break with the past. And actually, we can tell you, you should probably break with the past sort of like 4 years ago, right? That's kind of your optimal like novelty quadrant, right? And then if you look towards the future, okay, those highly cited papers are less transient, right? Future papers are closer to highly cited. And we'll talk a little bit about how the subfield dynamics work out. This is not necessarily a good thing, right? But at least it is the way the world works, and we say this is maybe like the second law, right? The system honors, right? It's a high-risk strategy, right? You can go out here, right? The further out you are, the more likely you are to be forgotten. But if you actually do want to do something, right? If you do want to make a dent, right? Go out here. This is maybe also a strategy for how to hire in a department like this one. You can play around with this. I was a little pleased to kind of break not individual papers, but papers coming out of different departments. And you can say, okay, is this department a high novelty department? Is it a low novelty department? Is it a high transience department? Is it a low transience department? It turns out one of the great low novelty, low transience departments was one of my old ones, Indiana University. So low novelty means they're kind of doing the stuff that people are doing. Low transience means that it's solid stuff. It's going to keep being done, right? There are some really unfortunate departments that have low novelty and high transience. So they're the people who write the paper and everyone's like, okay, like that's not, no one, just shut it down. There are also, these are fun ones, they're the high novelty, high transience places. These are kind of the nutcase departments where it's like, right, just they're throwing stuff in and everyone's like, and I won't tell you which departments those are. This is IU. This is the high novelty, low transience sort of winner, quote unquote, the Institute for Advanced Study. And so what we have here is a histogram essentially of department level, group level strategies. Interestingly, yes, the Institute for Advanced Study is a high novelty place, but in fact, half of the, or more than half of the IAS papers are essentially like Indiana University papers, right? So IAS is not out here, it's actually sharing, right, the people there are sharing a lot of the strategies. And I'll just point out, I haven't shown you any examples here. This is the most extreme paper, the most extreme novelty paper that came out from the Institute for Advanced Studies, a paper by Natty Seiberg. It now has 1,100 citations. It's one of the most important papers recently in string theory. And then you can go down to the other end here, and this is a low novelty paper. It's the Institute, so people still give a lot of citations. And this is something that is essentially trying to kind of tell a story about a bunch of stuff that's been done. So you have divergent strategies, you also have divergent skills. And so there are in fact quadrants here where Indiana outperforms the Institute for Advanced Study. So in this portion, the triangles are IU and the dots of the Institute for Advanced Study. You'll notice at this level of novelty, the Indiana University papers have lower transients than the Institute for Advanced Study papers. Like Indiana is good at doing intermediate novelty stuff, right? When the IIS tries it, it actually doesn't do as well. Over here is where the Institute of Advanced Study excels, which is these higher novelty places. That's actually where they have lower transients than IU. There's finally this question, and it's not just a question of equity or unfairness, but it's also a sign perhaps that there is greater intellectual resources to be gotten out of science than citation structures allow us to discover. I think this is one of the most critical things, right? Science is no longer something that gets done at one or two places, Oxford, Cambridge, MIT, Caltech, right? Science is now something that is spread globally. And one of the questions we have is how can we find the new? How can we find the resonant? So here's a plot, right? This is now resonant, so it's that distance off the axis, which is strongly correlated with citations. But now we're going to break it out by department. And so one of the things you'll find here, right? So that's an IIS paper, right? So this is log citations, right? So citations, there's this kind of get richer effect, right? That, you know, there are really extreme citation papers, right? So, you know, here's this is a highly cited paper that has negative resonance. So this is a paper that is novel and actually doesn't have the pattern influence that you would expect, right? And it's sitting out here, right? But notice a paper, for example, like this one. This has non-trivial, both large effect size and significant deviation from the 0 point, right? But looking at other papers at that level of resonance, you might say this is an under-rewarded paper. It doesn't have as many citations as it ought to. So what we're doing here is we're trying to go beyond what people say they're doing and look at actually what's happening. I'll get to you in a moment. Citations, right, are how scientists reward each other. It's how scientists talk about what they're doing. But as any good psychologist or cognitive scientist knows, what people say they're doing and what they're actually doing are two very different things. Yes, question?
Sorry, yeah, just a clarification question about resonance versus citations.
Yeah.
So I was under the impression that resonance was a measure of number of citations that you get across time after you've published your thing?
So resonance is this, it has nothing to do with citations, right? Resonance is this measure of the extent to which you've broken the patterns of the past, right, measured using Colback Hyperdivergence, and the extent to which that new pattern, if there is a new pattern that you've introduced, persists forward.
Okay.
Right, so this is in some sense, this is picking up the kinds of things that you're doing when I actually look at what you've written, right? Which is very different from who you choose to cite, right? And who you say influenced you and the relationships that your work actually has conceptually or technically to the work that's come before. So one of the ways to think about this is citations are what we say we're doing, right? This is what is actually happening. All right, so I'm going to tell one more story about string theory, and that's a story told about what's called the Randalls Syndrome model. The focal person on this one is Lisa Randall. This is, in fact, the most highly cited paper in our archive that has unbelievably runaway influence. It's the most highly cited paper, sorry, in the theoretical sciences, or in the theoretical physics world. Lisa wrote, in addition to this paper, ended up writing a popular book about this mind-bending reading, engaging and remarkably clear. The book is called Warped Passages. So what has this paper actually done? String theory. Let's take a look. So this here is this is the entire archive, and what I'm showing on the x-axis here is the number of citations that a paper has gotten. And on the y-axis, I'm now looking at the Colback-Leibler distance to papers that cite you. So this is the extent to which a paper that cites you also imitates your patterns, okay? And obviously there's going to be some action here, so I'm sorry about the scale, right? So there's a couple fun things you can notice right away. Notice that, sort of, and I'll put the line up here, notice that as you get more citations, the papers that cite you actually get closer to you. Just sort of fun, right? Another way to say that is that if you only get like one citation, like people are like, what? Right? Like you've done something and they only, like when people cite you, they actually don't really do things that are like you, right? So in fact, as you become sort of more influential, have higher status within the system, actually the people that cite you get closer and closer. We can also put up, this is the Randalls Syndrome model paper, and so this is just this one paper. You can see how far out of the range that it lies compared to everything else, right? In this case here, right, the papers that cite Randalls Syndrome theory are remarkably close. In fact, they're just basically, they look like all the other ones here. One way to think about this is that, papers in this range here are fitting into a field, right? The papers that cite them are kind of like the paper that they cite, right? I would say that in fact, what Randalls Syndrome did is actually create a field. So people are writing these papers, the people that are writing papers that cite Randalls Syndrome theory are actually in the process of co-constructing an entire subfield of theoretical physics, which is essentially like doing the stuff that Raman and Lisa did. Right? So now let's go to the next level here. So this is the second order citations, right? So second order citations are how far are you not from papers that cite you, but from papers that cite papers that cite you, right? So now take 2 steps away in the citation chain. So the first thing that you see, and this is of course a little bit what you'd expect, is that papers that cite things that cite you are further away, right? You've gone further out in conceptual space, right? What we see here, in other words, is this sort of reuse and retooling, right? Your work has now influenced somebody, and that person you've influenced is influencing other people downstream. So what we can see here is the propagation, as patterns propagate through this system, right, they become increasingly distant from where they began, right? So I call this reuse and retooling, and now this curvature here is, it's pretty minor. Now you can really see, right, that these highly cited papers, right, are influencing a wider range of other kinds of things happening within the system, right? So if I take 2 steps away from a highly cited paper, what I find is papers that are much more distant from the original focal point than more low cited papers over here. The third order effects, of course, get even more extreme, and now, in fact, this line up here is what we call sort of the HEPTH, or the High Energy Physics Archive, Theoretical Physics Archive radius, right? So this is the average distance between 2 randomly chosen papers. And now when you go to the third order, okay, most of the sort of ordinary papers here don't really propagate too far compared to the full radius, but the really highly cited ones are now effectively influencing almost all of the physics that's being done within this system. Papers that are really distant from each other are 3 steps away from you. You think of this as sort of a small world effect, right? But instead, right, so the small world effect says, basically to get to anybody in the world, I only have to take a few steps, right? This is measuring, okay, if I step along your social network, how different or how diverse are the people that you encounter as you take that walk? That's Randalls Syndrome theory. So in fact, this theory has effectively achieved complete field dominance in the sense that you take a randomly cited paper, or you take a random paper from the archive, it's within 3 steps of random. There's a problem, and I might call this, instead of the random central model, the random central crisis, is that the fact that this paper, which came out in 1999, is wrong. It's a paper that claims that there should be an effect. It was very exciting. There was no such effect. And we modified and modified these models. We found no evidence for this effect in any way. So what we have here is we have a theoretical paradigm, a way of doing science, that establishes its own field, right? That establishes, in a sense, a network of papers that all imitate it or look like it or draw from it. And not only that, but the sort of viral effect of that paper now influences the entire string theory archive. And yet, is that a good thing for us? Another way to see this, sorry, I'll put this up together. Another way to see this is the difference between the theoretical sciences, or at least where string theory has ended up, and the experimental sciences. So if we compare the theoretical chunks of the archive, and this is slightly different from the string theory one, just for fun. This is the general relativity and quantum cosmology. It's a theoretical one. What I'm showing you here is the resonance as a function of time. I've broken up resonance, so this is resonance here. Resonance is a function of time, and I've broken it up by top 10% and bottom 10% of cited papers. So what you say is, what you see in the theoretical archive is that the highly cited papers, in theory, increase in their dominance, increase in their pattern dominance of the system over time. They just keep growing, right? So this is the 0 point of resonance. At relative month 0, in fact, you're comparing to papers that are coeval with you. So in fact, there's no difference between novelty and transience, right? As you go further and further out in time, you look 5 months forward versus 5 months back, 12 months a year, and I go up to 2 years here. As you wait longer and longer, those highly cited papers increasingly dominate the patterns of the system. And compare that to, conversely, the empirical or observation-driven sciences. So this is the astrophysics one. So in this case, astrophysics is the archive here is driven largely by papers that are coming in about observations. In this case, even the highly cited papers fade. Right? People do experiments. These experiments are considered very good. They influence people in the sense that they enable them to do new science, but the new science that they do looks different from the science that's happening in that paper. So while theory appears to be a case of like, you put a stick in the ground and everybody has to sort of stand near the stick, right? The empirical sciences, at least as far as we can tell within this archive, and what's wonderful, of course, we can directly cross-compare them, right? What happens, what appears to happen in the empirical sciences is that people actually make progress. The papers that matter, okay, don't matter in a way that prevents the field from generating newness. Any questions on science? Okay, let's talk about revolution. The French Revolution is sort of like the American Revolution, except it goes drastically wrong. It's a disastrous revolution. The way it began was King Louis, who was a disastrous king, ran out of money, as kings tended to do. He spent poorly. Actually, he spent it in part upon the American Revolution. He needed to raise taxes. He was unable to get consensus around this. He was unable to get people on his side. So he decided to sort of invoke the nuclear option, which was to convene something called the Estates General, which was this ancient tradition where you got what were called the three estates, the nobility, the clergy, and what's called the third estate, and no one really knew what the third estate was. It turned out to be lawyers, unfortunately. But really what it was, of course, the middle classes. He convened the third estate, and they were going to decide, they were going to help, come to agreement to allow him to raise taxes. The last time the Estates General had been convened was 160 years beforehand. So nobody had any idea what this meant. Okay? But in 1789, compared to the 1600s, one thing did happen, which was the Enlightenment. And so people showed up, and instead of helping the king raise taxes, very quickly they decided to hold a revolution. Okay? Famously, the king tried to shut it down. The room in which the Estates General was meant to meet, the nobility showed up and the clergy showed up, and then they locked the doors. And so the bourgeoisie were like, nope. So then they actually went to the tennis court, which was more like a squash court. They went to the tennis court and they held what was called the tennis court oath, not to leave Paris or Versailles until they had, solved the problem and made France something not what it was. What exactly were they going to make it into? They sat in a debate hall in a parliamentary chamber. Over the course of 2 years, they wrote a constitution. Remarkably, we have transcripts of what they said. Now, in some cases, these were directly taken down while the people were saying them. In other cases, they are reconstructions that historians have done. But remarkably, actually, in the 19th century, French historians had this sort of multi-decade project where they produced a synthetic reconstruction, sort of archaeological reconstruction, of what was being said moment to moment over the course of not just the writing of the Constitution, but then the legislation or the actual management of government that happened afterwards. So in this case, instead of 70,000 string theory papers, we have 40,000 speeches by revolutionaries. Many of them are really boring, okay? So, every day of the revolution begins with a reading of the minutes from the day before, right? So this is like faculty meeting that goes wrong, right? Everyone, half of the faculty killed the other half in the end. So, and then it's like, okay, we're going to read and then this bishop has a complaint about the minutes. Like, great, okay, what are you going to write? And it's like, well, in the minutes it said that the monks gave this gift to the revolution, but actually it's the monks don't, they don't own it, so it's not really a gift, right? So they argue about that. Some of it gets really exciting, though. This is, does anybody here speak French? All right, so maybe you can sort of read along with me, right? So this is like chaos in the chamber. Somebody says, I want to speak on this, right? And then a bunch of people say, order, you can't speak. And then somebody else says, you don't have the right to speak. And then somebody else says, Mr. President, like I want to speak actually, and I want to say that you're just doing this wrong. And then the first guy says, I did 4 things. I just want to say 4 things. And again, somebody else complains about what's happening, and then it just descends. So the left, the left in the chamber says, why are you speaking? And the right of the chamber says, or actually in the middle of the chamber says, let it speak. And they debate. At the end, they say, look, if this discussion is going to continue, Robespierre has the floor, which it turns out is a terrible idea. The revolution is not just fun because it's a revolution. It's actually fun because this is where the origin point of democracy. We like to say as Americans, or some of you are citizens, we like to say that the American Revolution showed everyone how to do it. That's not true. But they had a very different thing to do, which they showed up in a country that wasn't their own, right, and made something out of nothing. The American Revolution had basically 50 people in a room. Here, there's 1,200. Okay, so it's like the large end limit, right? These are like neurons, right? There's a lot of people here debating and arguing, and in fact, these stories here is actually where the European democratic experiment began. That's why the Europeans call it Parliament and not Congress. Okay? We can do topic modeling for the French Revolution, just as we do in the case of physics. These are much more interpretable. So one of the things you can see, for example, is our topic model pulls out patterns of speaking that are about logical disagreement. So in fact, in this case here, so here's a speech that was heavily weighted on a certain pattern, topic 94, and it turns out they're actually making a logical argument, like a deductive logical argument. Here's another one. This is a different topic associated with disagreement over which articles to adopt. This one is fun. This is a topic associated with literal depictions of people like coming to blows in the Parliament House itself. What you should take away from this is that our patterns, the patterns that we uncover, just as in the case of the string theory archive, actually have conceptual content. They seem to be hooking into both the kinds of arguments people are making, the things that they're talking about, and the ways in which they're talking about it. We're a long way from the Lego brick model, right? You can't sort of glue together fighting with disagreement over adoption of articles and logical disagreement. We're a long way away from the idea that there's like a finite number of things, and we're on now a story about how people are modeling or building models about what everyone is doing. So we can do the same thing that we did with the physicists. We can put the speeches, each of these speeches, onto a novelty transient plot. Here's what it looks like. This is the string theory one. This is more of the data here. Those white dots are Carnegie Mellon's physics department, which I put up just for them to see how they were doing. What you see, as we said before, was this strong covariance. Here's the French Revolution, and once again, right, new speeches that break the pattern tend to be forgotten. We can look backwards and we can look forwards. One of the things you do see is that this right here is actually a great deal wider than this right here. So I'm going to show you a few things you can do with this. This was actually a paper that came out in PNAS last week, so you should read it. And I'm happy to give you the reference. One of the things you can do is say, okay, look, who are the people lying in these different quadrants, right? Who is sitting, and this is now resonance versus novelty, who's sitting in the high novelty, high resonance location versus the low novelty, low resonance location, right? Who is the Lisa Randall of the French Revolution? Who is the person or the Natty Seiberg of the French Revolution? Who is the person who breaks with the patterns of the past and introduces patterns that persist? Right? If this makes you think of biological evolution where creatures mutate, most of the mutations die, some of those mutations are particularly advantageous and stick around, and that's not by accident, okay? So who are the people who are able to inject persistent newness into the system? The answer is the radical left. It's the hardcore left-wing members of the parliament. I didn't mention this before, but in fact, of course, left and right come from the French Revolution. It's just all the left-wing people sat on the left and all the right-wing people sat on the right, so we call them left and right. The radicals, and in particular a man called Villeneuve and a man called Robespierre, are the drivers of novelty, and they're the drivers of persistent novelty, right? There are also high novelty people who sit down here. These are the people who are like kind of, they can't quite get it, right? They're trying to be like Robespierre, they're doing things, they're injecting novelty into the system, but they somehow don't have the charisma or the argument pattern or the whatever it is, whatever oomph it is, to get those patterns to stick around. Interestingly, we also have the people at the low novelty, high resonance end, right? So these are people who are saying things that aren't particularly different from what's come before, but they're able to do so in such a way that they stick around over and above what you would expect. Interestingly, this is the right wing. Okay? So what is the right wing doing? I haven't told you anything about what they're actually arguing about. All I'm talking about is how this information, these pattern making and pattern breaking things are propagating through the system. Right? So while the left wing is sticking new things in, right, that if you're Robespierre, stick around, the right wing is actually trying to keep the conversation on track, right? So if we're having a conversation and like Paul is like, hey, we should really, I don't know, dissolve the department and make a new department, right? And so he injects some novelty in the system. If I'm on the right wing, I'm like, okay, let's talk about that. Okay? What the right wing is doing is imitating or keeping the patterns of what's come before. And they're able to do so, in fact, so that pattern persists going forward. I can show you, this is just the tennis court oath that you remember from the beginning of the civil section on the French Revolution. These are actually the revolutionaries in that, so these people, these figures are actually real people holding, coming together to hold the oath not to betray the principles of the Enlightenment or the revolution itself. We shouldn't say Enlightenment because we don't know what that means. Let's take, for example, someone down here. This is the low novelty, low resonance quadrant, right? These are the people who say things that nobody listens to and that actually nobody follows up on, right? So there is our, that's Barnave. You can see him in the back here. Robespierre, that guy there. So, we can do a great deal of fun stuff if you're a historian, and I should say one of the tricks that we discovered, not trick, one of the things that makes this research, I think, particularly compelling, is that we don't just sit around and do this as ex-physicists, which is the standard mode of doing things, but we work very closely with historians, in this case, particularly with a historian back at Indiana University, Rebecca Spang, who is sort of one of the experts on the phenomenon we call the French Revolution. She's written monographs on the various phenomena that show up there. And she is somebody who is able to tell us what the basic questions are. In fact, one of the things we hope to do at the beginning of this research was, in fact, when we sort of switched this on, we figured that what we would find is exactly what you find when you do this in the congressional record in the 21st century, which is we thought we'd find speech patterns associated with the left and speech patterns associated with the right, and they just split apart, right, in some kind of polarization thing. We actually see no polarization at the level that you would expect. We see some detectable stuff. We don't really see it at the level you'd expect in the French Revolution. Another way to say this is they're actually having a conversation. They're talking about the same things. What matters is the way in which they relate to others in the system. I'm going to skip over this here. This is another thing we discovered. When you go to data this size, and you go to data that no one's actually ever looked at before, of course the French Revolution is a great topic, but nobody has run Colback Hyperdivergence on it. I'm really certain about that. PNAS will not let you make a claim to novelty, but we did, okay. We also cite both Foucault and Bill Buckley in that paper, which I think is a first. One of the things that Alexander, the graduate student working on this project, really drove things is that he noticed that in fact there was in this resonance versus novelty plot, there was this emergent little clump that was doing something rather odd. It was a clump of speeches that were high novelty and low resonance, right? So they were sitting off here. Okay? And so these look like speeches that are in fact speeches that don't matter. People say something, it looks different from what's come before, fine, but it disappears. And it really disappears, right? This pattern comes in, and literally the next thing is a pattern that's completely different. Right? So what is this little clump that sticks out, right? It looks like this sort of crazy crank clump. It actually turns out to be a new emergent power center within the revolution, which is because these guys are sitting, and they're all men, okay? They're all in this parliament room, there's 1,200 of them, and they realize that they have to run a country. And it turns out you can't run a country in a room of 1,200 people debating about the philosophy of law, okay? You actually have to get things done. And so what they started doing was they started farming out problems to these committees. So the committees left the room and met and worked something out. At the beginning of the revolution, the way these committees worked essentially was like they'd figure something out, they'd bring it back to the parliament, and everyone would talk about it. Over time, and this is the emergence of this clump, over time, in fact, what happened was the committees met outside the parliament room in secret in a sort of fundamentally undemocratic fashion. They were not transparent to the other members. They came back, the committee said we should do this, and everyone was like, fine, just do it. We're not even going to talk about it. So the committees show in, they introduce a pattern that no one said before. It doesn't get debated. In fact, what happens, and you can sort of, and this is the sort of genius move in Alexander, who's actually looked at these, you find that these are committee speeches, and at the end, it says, accepted without debate. Committees propose and dispose. Here's an image of the evil committees. They invented them, right? I mean, of course, the nobility had to farm things out as well, right? If you're a political scientist, this is a fundamental question in democracies today. How do you manage information? Right? The fantasy that you're taught at middle school is that, you know, we just, okay, fine, we maybe elect people, there are sort of representatives, and they go in, they just hammer things out, like a little bit like town hall. That is not how democracies actually work. And what you can see here, from the first half of our data to the second half, is the emergence of that. This is not Robespierre, this is not the great, you know, the charismatic figures of this world. These are actually the backward ones. All right, so I have one last thing to tell you. I didn't come here to talk about the French Revolution. I came here to talk about the internet. The French Revolution is actually very similar to most of the things that come afterwards because it's a conversation. People sit in a room and they talk to each other. Okay? And when we do that, we have to take turns, right? Now, okay, yes, right? The French invent, or the revolutionaries invent the committee. So instead of just a linear conversation, you kind of have this data coming in from the outside. So there's this new information kind of plowing in. And just to be clear, right, it really is information in the Claude Shannon sense. These are new patterns that haven't been anticipated. Right? So this new data is coming in. But by and large, it's a conversation. That's how we've run everything. You sit in Congress, you talk it out. Okay? Yeah, farm it out to committees, the committees talk it out. You sit in this room, you talk with your collaborators, you talk it out. The internet changed everything. Okay? I don't know if you procrastinated your dissertation on Reddit, but the fundamental thing that happens, right, that the internet allows you to do, which has really not been possible before, is that you can fork the conversation, right? Instead of just a line where everybody's sitting in the room and you have to take turns, right, and Robespierre can derail things, right, or the right wing can try and keep you on topic, if you don't like this conversation, you can fork it, right? Two people can take that conversation in two different directions within the same system. We have no idea what this does. It's been around 10, 15 years, at least as a dominant political force. We have no theory, we have certainly no political science, right, on the fundamental discourse that this topological change means for culture, for governance, and for human interaction. We just don't know, we just don't understand. So Zach, excuse me, sorry, my slides are repetitious. One of the things that our graduate student of mine, Zach, is working on is how, if you're able to fork this conversation, right, because people can't really pay attention to all the forks, one of your problems when you fork it is not just continuing that discussion to work something out, which you hopefully are doing, but also gaining the attention of people. Attracting people to follow your thread versus the other thread. And this is a constant problem. At any point in time, right, at any particular post within that system, somebody, right, can fork it. But if they fork it, they want to be attended to. They want that fork to actually do something, one hopes, right? So at every point in time, people are trying to work out where they're attending, where they should pay their attention, and the moves that they ought to make in order to continue attracting attention from others. So this is preliminary work, we're really excited about it, but what we're trying to do here is take a fundamental, and I understand you guys are really interested in attention, right? Take a fundamental cognitive process and say, how does this affect the nature of forking discussion? So here's a couple things that we found. So on the x-axis here is Colback Hyperdivergence from a focal post to the children, or the descendants. And on the y-axis here is upvotes. So on Reddit and many of these systems, you can sort of say like. You can like something and you can upvote it, right? So this is a measure of how much people like this comment as a function of what the descendants do. And one of the things you find is that the Colback lidar distance is not very close. So these things here, it's a little bit different from physics now, right? A highly liked post, the children are not copying it, but nor are they deviating too far. They're in some kind of zone here where the pattern that that post sets up engenders or generates patterns that are different but not too different. If you look at the relationship between the focal comment and the parent, however, you see a very different pattern. So now, right, a highly, this red point here, if this red point is highly, is upvoted, if people are attending to it, one of the things that you find is that it has broken with the parent pattern. So to be attended to, you should break with your parents, right? And you should engender children who don't respect you too much. And finally, you can say, what's the relationship between this thing and the initial post on that particular branch thing? And now, in fact, this comment here is highly voted, if in fact it's close to the ancestor, right? So respect your ancestors, kill your father, and produce reasonably creative children. All right, so it's a pleasure talking to you. We have time to chat. We've covered a lot, so here you go, and break patterns. Thank you. Yes?
So, you're talking about splitting the conversation. How is that any different from what's happened throughout history when there are multiple schools of thought on a topic, where people take from the same conversation, from the same idea, they literally branch off and form like different groups, different societies, different publications, and we have different schools of thought in every topic on every branch of science already.
Yep.
So how is this something that's unique and different and new?
What's this? You're talking about the work on the string theory archive?
Well, you're talking about that forking the conversation.
Oh, yeah, forking the conversation. Yeah, okay. Yeah, so what we're able to do here is not just say, I mean, yes, obviously, right? If I say something and people like it, what it tends to do is it tends to engender new things. I think that's what you're saying.
I mean, it's the same that we have different schools of thought and different philosophies and everything from, from behaviorism to physicalism to, like, in any field, we have different attitudes and different populations, different publications, depending on which people think people side with more.
Yeah.
So it seems like the conversation has been splitting forever.
Yeah, you think that's true, it's not true. The successful fields do that. Cognitive science does that, right? But some papers, right, some departments, right, some endeavors never do that, right? Their descendants look exactly like them, right? They don't branch, they don't split, they don't produce a diversity of offspring. Other fields, right, are so centrifugal, right, that the things that follow them bear very little relationship to the parent. Right? In some sense, what you're saying, and I agree with this, there's a selection effect. It is true that all the things we call fields have that property. There's a lot of phenomena that don't, right? There's a lot of what we wouldn't even call them fields. There's a lot of endeavors, group endeavors, that have very different things. Yes, question?
So actually, two questions. One's a quick follow-up to that one. So with the structure that you're talking about in the forking, it sounds a lot like, what is it? I'm curious how that's distinct from citing a paper and starting a parallel project of sorts. So,
right. So this is an interesting one, right? So it's a little hard to see here. Think about the Lisa Randall paper, right? So the children of that paper look a great deal like the original, right? That's why we say in some sense Randall has created a field, that Randall Syndrome theory became a thing, right? Now take Zach's work and take a look at the descendants here, the children of that post. In fact, in the case of Reddit, at least the way that upvoting works, it so turns out that the children actually look different from the parent in a particular way, right? In a way that's distinguishable, for example, from a low voted post or an average voted post, right? So what we're able to do here is, okay, first of all, put things on the same axis, not just compare theory to experiment, but science to revolutions to internet conversation, right? But we're also able to tell a story about how this might be different from this, or in particular, how a linear conversation that we've had for 100 years might differ from one of these. You had a second question?
Yeah, the second question was with regards to your diagram there, given the text that I've just encountered.
Oh, yeah.
Not surprised by what comes next.
Yeah.
The question that I have is, you can measure the KL distance between your next paper and your current paper,
Yep.
or you know, any of those in a sequence.
Mhm.
But how about without or outside of the field that you're operating in? So, for
Yeah.
instance, is it the case that my conversation is becoming more novel relative to the rest of the discussion that's happening in my field, but it's becoming more similar to discussions that are happening outside my field, but maybe my neighbor's having that?
That's great. That's a great question. I mean, one of the things is that we don't really know what a field is, right? And so we were just talking about ASU, right? Like, okay, now it's not physics, it's like a subset of Earth and space exploration, right? So fields are human constructions, just as citation patterns are, right? You know, in some sense, okay, the further away you move in KL, right, maybe that's sort of less fieldy, you know, the less field memory you are, right? But I would say it's an open question, and one of the nice things that quantitative work can do is say, look, in order to talk about things, we've had to invent boundaries. Maybe those boundaries aren't the right ones. And in fact, very often when we work on a historical project, not in the case of the French Revolution, but very often the historians will tell a kind of epoch-based story, like everything changed, right? Actually, it doesn't always work that way. Yes?
So I think I missed part of the argument in terms of, or what the alternative to the Lego brick model of creativity was. It seems like a lot of what you're talking about could be understood in a Lego brick way. In fact, you're literally comparing different arrangements of words, which is kind of Lego bricky.
Right,
So,
yeah.
I think I missed a step.
Yeah. So from the Lego brick model, right? What matters? What's new is taking these sort of discrete atomic units, right, of the same kind, right, that can be glued together, right? What we're doing here with this topic model, it's true that of course what we pick, you know, words are little bricks, right? They're not fuzzy, right? Like I can see them, right? I can pull them out, right? What the topic model does is it finds patterns of co-occurrence between those words, right? And it decomposes a particular text into a distribution over these patterns. But the patterns may not be meaningful on their own, right? The sort of the fundamental atomic unit, if you want to think that way, right? So one way, I mean, I say this in a kind of shocking way, say it like Lego brick creativity is wrong. Another way to say it is, whatever those atomic units of creativity are, they're not cognitively accessible to us. In some cases we can see, oh, this is kind of a causal argumenting thing, right? But that's a very different kind of thing from a pattern associated with enemies of the revolution, right? So we're no longer, you know, object, camera, phone. We're no longer, you know, Abraham Lincoln and zombies, right? We decompose these things not into combinations of knowable objects, but rather combinations of patterns in the models that people build out of those. Yes, in the back.
Just to play devil's advocate
Yep.
with that, is there a way to look at which patterns are contributing most to the novelty and the resonance effects within a speech? Because it really still might be a Lego brick thing that just has all these features in it, but like really it's these two components of things that made this a resonant argument.
These are the salient bits, yeah.
Right.
So in some cases, yes, right? So some cases you might say, okay, look, there's you know, this speech has pattern 1 and pattern 2, and this speech has pattern 2 and pattern 3. So really what's going on is you dropped 1 and you stuck 3, right? And so in some limits, right, the Lego brick model returns, right? But only if you know you have uniform distributions over the patterns. And I would say also, right, even if you know as long as the particular patterns in play that are switching, right, are the same conceptual units. Right. So it seems that, you know, would, for example, let's say that, you know, I switch from, you know, you're making a causal argument about X, right? And I make a causal argument about Y. Well, maybe I've switched out X for Y, but say you make a causal argument about X, right? And I make a logical argument about Y. Is a logical argument a brick that you can glue together with any other brick? I don't think so. Yes, question.
Well, that's me?
Yeah, it's for you. Yeah. Go for it.
So there's something very interesting about that graph between novelty and transience. So
This one here.
yeah.
Yeah.
So you know, editors nowadays take a look at your paper and they make a subjective goal as to whether it's novel or not, and they often reject you or not based on that.
Yep.
And I think the implicit argument there is if your paper is perceived to be novel, that means that it's going to fare well down the road. And what you're saying is, well, we can quantify novelty, but to quantify resonance, so where
Yep.
it felt,
Yep.
right, so we need to wait
Yes.
enough time
Yep.
to quantify transients, right?
Yes. You cannot use this to make tenure decisions.
Right.
This is, I mean, it's or may, right? This is letting the system tell us.
Exactly.
Yeah.
So there's a couple of things I want to know.
Yeah.
First, is it because your measure of novelty is just fundamentally different from what they had in their heads,
Mm-hmm.
and yours is just a proxy that isn't, absolute or good enough?
Right.
And second, if that's not the case, is there any way in which we can predict resonance based on novelty?
So, let's see if I have the plot here. I don't. The French Revolution and string theory have many things in common. One of the things they have in common is that they are novelty biased, meaning that your resonance tends to go up as your novelty increases, right? These systems do preferentially, at least statistically, right, tend to give higher resonance to things that are different, right? So, if that ever switches, we might be in trouble. Right. If it ever is the case that now the more new you are, the more quickly you fade over and above the expected level, now we start to get concerned, right? So it is true that we are novelty biased. The next question is, of course, okay, what novelty, what's the crank paper and what's the genius paper? Mm-hmm. One of the jokes I tell is I can tell you the difference between a genius and a normal person, but I can't tell you the difference between a genius and a crank. Mm-hmm. Because both the genius and the crank deviate from what's common. Maybe this is the demarcation problem, right? It's hard to say, right? This seems to be a fundamental question. It's an awful thing to say, but science is not just this normative process that keeps improving. And I suggested this a little bit. We haven't done the full analysis, but social prestige of your institution does matter.
Right. But do you see resonance going up with novelty in papers?
Yes. So in the string theory case and in the French Revolution case. So both of those systems are novelty biased. That seems to be a way to classify different things. It looks like Reddit may be anti-biased. Yes?
So if you had a large enough corpus, could you identify a subset of items that are high novelty, high resonance, and characterize the joint probability distribution of features over that set as compared to a set that does not have high novelty and high resonance or something like that?
Absolutely.
And thereby perhaps try to characterize what's different about the general class of papers that end up in that part of the space.
I mean, this is sort of following.
It's very similar.
Absolutely, yeah. So one of the things that most of these systems that we see are evolving, right? In part because the system is novelty biased. They're different. 1999 is not 2008. So some kinds of patterns that give you high resonance in 1999, like for example, Lisa Randall's paper, will not give you high resonance in 2008, right? We ran this analysis on the philosophical transactions of the Royal Society. So from 1665 to 1885. So this is essentially the first scientific institution and the first scientific journal. I was really pleased. The highest resonance paper in that data is not by anybody in Britain, but is in fact Ben Franklin's kite experiment. And what's amazing about that experiment is that it joins together two things. It does two things actually. One is it reveals a fundamentally previously not understood nature of theoretical physics, that electricity is some kind of fluid. It's not a presence-absence thing. But it also is this new industrial technology, the lightning rod, right? So one thing that you might, for example, say is, okay, high resonance papers, at least, let's say, in the course of science and the Industrial Revolution, might be the things that do both, right? They're weighted on topics that if you examine those seem to be kind of industrial applications, but also things that are theoretical advances. So that's maybe a story at a more abstract level, right? That doesn't depend upon, okay, look, we didn't know about electricity in that way at that certain point. I think that's going to be rather system dependent. I think we'll learn a great deal about that particular system. We learned a lot about electrodynamics by looking at that, but it would be lovely if you could find, right, a predictor of resonance. Paul.
Yeah, great talk. science and the French Revolution have something in common that most social systems don't, which is that they are novelty-driven systems.
Right.
Right. So science is all about the quest for new knowledge, and the French Revolution is the quest for something different than what we've had before.
Yeah.
So both of them are both intrinsically, by the virtue of the system,
Right.
novelty biased.
Yeah.
And most interactions in the world probably are going to have the opposite bias, right?
It's a hypothesis, Paul. I'm glad we have you on the record.
Yeah, I said probably.
We're going to pre-register this one.
Yeah.
I'm teasing a little bit here, but so what's funny is that like we don't know, right? And
But it's probably true.
It's probably well, we don't have to put it this way, right? You know, like take Soviet Union, right? Like the Bolsheviks were like the anti-novelty bias thing. They killed anybody who deviated from the Bolshevik pattern. So, but anyway, you were going to say, sorry, Paul. I mean,
No,
yeah.
Sure.
Yeah,
That's
right.
a counterexample, but
Yeah.
but to the revolutions are always
Yes.
novelty
Yeah.
seeking,
Yeah.
but not to the quotidian language is probably not novelty seeking.
I wonder about that too, and the reason I say that is I'm a little bit on the Howie Clark story here, which is that pattern breaking is how we attract attention. So that in conversations, in discussions, we have a certain kind of novelty bias. So I guess my anti-prediction is that in fact many more systems than you would expect are actually like the basic default mode of humankind is novelty bias, but we'll see.
Yeah, I don't think that's true.
All right. I was thinking, who was it when we had our discussion at lunchtime today, which was really fun. You can notice, right, once you do this a lot, you notice like some people introduce patterns that stick around. And you notice a little bit, because like, oh, okay, Dave said this thing, and I want to follow, right? So like Dave's Robespierre of that meeting. But there are also some more subtle things happening. We've pitched this to political scientists. Anybody who wants to do this, is really easy. Come find me. We pitched it. There's too many different things to do this on. We're interested in. I guess maybe I'll say this is obvious too. It made me cry, which is we had this data from the Serbian parliament, and the Serbs from I think '94 to the present day. And the Serbian parliament in the 1990s was not really a parliament because it was under a dictatorship of Slobodan Milosevic. And so we see as the dictatorship falls apart and eventually Milosevic leaves, you see the novelty bias come up. Right? But again, I guess maybe these are things that we knew from other angles. Yes.
So at one point, I think you kind of compared scientific progress to evolution.
Mhm.
So could you do this on genomic data?
Yes, I really want to.
Yes.
Biologists are much more secretive about their data.
Mhm.
So the French Revolution was digitized for us by the Bibliothèque Nationale in Stanford. Just give it away. The archive, it's open access. It's really hard to get access to, for example, a colleague of mine, so you have old friends, right? So James O'Dwyer is a colleague of mine who's at the University of Illinois. He works on microbiome data. So let's look at the novelty and transients in your microbiome, right? New things come in, like it's probably not a good thing for your microbiome to be novelty biased. That feels like a stomach ache. The problem in that case was actually we didn't have enough time samples, right? So it's actually pretty rare that you have the long time span of, it's like 70,000, 40,000. As a rule of thumb, to do this kind of thing, your kind of minimum size is 1,000. Right? If you have 100 objects, you really can't get the statistical power. You need to define the patterns or to look at the laws underlying their propagation. So in many cases, we actually have been a bit stuck.
So
yeah.
I should note that UC Merced is one of the homes to the Open Tree of Life,
Right.
which you might want to look at.
Right.
All right.
That's what I was thinking. Exactly.
Yeah.
I was like surprised to hear you say that because I thought, being at UC Merced, I thought, oh yeah, all this stuff is becoming
There you go, right, okay.
and out there. Yeah.
Yeah. So I mean, the other thing I say, right, is that we always need to team up with people. So I know nothing about biology. I mean, I think I know Dunning-Kruger, but in each of these projects, one of the big not problems, it's fun, but it's also a challenge, is to get a domain expert on board. Because if you don't have a deep knowledge of that system, you're not going to be able to navigate it, and you're going to say really foolish things. One of the things you want to do on that note is we really want to run this thing here on the philosophical archives. We have a feeling that you're going to get, like, Saul Kripke is the Robespierre of analytic philosophy. we really want to get a better handle on this. Colin Allen, who's a collaborator of mine, we worked together on the Darwin project. Colin has a sense that philosophy is not about novelty so much as persisting in argument. That philosophers are fundamentally conservative. So it's like, okay, causation since, Aristotle.
Yeah.
So this might be a prediction that philosophy is a novelty anti-bias system.
So,
Yes.
can I
Oh, yeah, I hear.
right on it. Impact factor, could you see people using something like this instead of impact factor?
I know, right? And,
Right,
so
that's
I know.
now you
It's
say
like, yeah. I can tell you, right? I don't have to plot it, right? It's like, how do you have a high citation thing break with 4 years from the past, and your reward comes 2 years in the future? So when your tenure clock is right, you do it. These results are statistical, right? So there are points that lie off this curve that ought not to.
I see.
Because our pattern recognition, in some sense, what our pattern finding system is doing is producing models that it's an implicit theory about how people perceive papers. It's a really imperfect theory. And maybe this is a page for those people who do NLP or these things that kind of merge the cognitive stuff and the linguistic analysis stuff. The more you can tell us about how people perceive and respond to language, the more we can put these in here. You give us the models that tell us the patterns, we just grind it through novelty transients, and out the other side, we find all sorts of roles that people play, all sorts of evolutionary effects. But I think this is fundamentally a cultural evolution story. Who was I talking to this afternoon about this? I think there is something different about humans that are at least cognitive systems and cultural evolution, which I think we are novelty bias in a way that biology can't be, right? If your doctor says your child's genome looks really different from all the other ones I've seen, that's a really terrible sign. But when Nadi Seiberg writes a paper that looks like nothing else, it's a really good sign. There was a question in the back, yeah.
Yeah, so there's a fairly resonant view in discourse analysis that the way in which we couple and coordinate with discourse partners is we use recurrent syntactic or semantic structure to convey some meaning that aligns with them, and then we diverge. So we say something new, and we sort of mutually pull each other along in a conversation. And maybe this happens over the time scale of 30 seconds to a minute, something like that, right? Yep. So one thing that I was thinking about when you were presenting the results, contrasting theory against empirical work, is whether actually if you were looking at a time scale of 5 years or 10 years instead of, I think it went out to about 30 months, if you would start to see more of an inverted U shape, and you'd see that theory actually does progress, but it takes a longer
time, right? Yeah, so I was comparing here the theoretical and the empirical sciences, right? And so maybe, if you wait long enough, they start to decline. If you're a Kuhnian, right? That decline is the death of a paradigm, perhaps, right? Whereas the empirical stuff is just constantly reinforcing normal science. That's the flip way to say what I was saying, which is like these theories get too anchored, and that's a disaster for the progress of science. The timescale question is really good. Because we work on this archival data, our minimum timescales, I guess in the French case, we have the speech-to-speech, so that's sort of minutes. It would be lovely to run this not just on biological data, evolutionary data, but also on really rapid timescales in the human brain, or really rapid timescales in the coordination, let's say, so physiological coordination you and I might have when we talk to each other. Yes?
Your response to Jeff about topics being not necessarily conceptual or somehow subconceptual reminded this old man of connectionist claims about representations over vector spaces, including dimensions that are subconceptual. And it's really a position in a vector space that is carrying content rather than any given dimension. Now, one of the interesting things that have been done in models of that kind is to show how what looks like a smooth trajectory through that vector space can eventually become a new meaning in a way. You can get inflection points in the trajectory, so that small incremental changes that appear to be nothing in a meaningful sense become meaningful at some point when the magnitude is large enough. So they're like developmental models that rather than have children go through developmental stages, show that if you just incrementally change things little by little, you hit a nonlinearity, and now it looks like a stage change. With regard to this, it makes me wonder whether there might be a way to find the predecessors to a highly innovative work, right? Find the patterns that aren't quite large in terms of Colback-Liebler,
right?
But they're heading in that direction and could kind of capture a zeitgeist kind of phenomenon.
That's great. Yeah, I mean, this is, so the joke is like, I don't know if you guys noticed this, right? Like, I said, the question is, you know, where do new ideas come from and what do we do when we get them? I basically told you what we did when we get them, right? And there's this much harder question of so I love this idea, this sort of precursor. In some sense, what Lisa Randall did was create a new field, right? She created, now we can always decompose this into, you know, we can have an arbitrary vector space. This is another reason perhaps you might say it's not Lego bricks, right? Is that I can just rotate all my axes,
Sure.
right? I don't know how to rotate axes in discrete Lego brick space. So, you know, it's okay for us to model Randalls Syndrome theory as a combination of prior patterns, but I think you're right that actually, cognitively, at that point, we actually see, oh, it's a Randalls Syndrome story. In fact, there's a name, right, that didn't exist before. And so I think what you're getting there is the ways in which our priors are actually shifting, right? And that in fact there may actually be now a sort of pro-selection for particular combinations over and above what you would expect from these other features, which is lovely. I also love this idea of the sort of the entrance genealogy. One of the things that has been sort of fun is there are papers that should be more cited. There are papers that look really influential. And so, but they're not particularly well cited. And so I've been emailing these people, and I haven't told them why I'm emailing them. And I've said, hey, I happen to be doing this study, and I'm wondering, just tell me about the conditions under which you wrote that paper and what you had in mind, and tell me, you know, did you like it? Do you think it's particularly novel, or do you think it's imitative? And so those answers have been coming in, and they're actually quite interesting. So we're hoping to do a little bit of that in the outcome.
Thank you. So one more question.
One more question. Make it. Anybody? Question? Oh. Yes. Go ahead.
So, just follow up to Paul's question,
Yep.
which was about the bias towards novelty that
Right.
you see in these systems.
Yeah.
My question is with regards to systems such as churches and other religious institutions. It seems like there's a very strong bias against novelty in a lot of these systems. Is it the case that there are factors beyond just sort of like idea exchanging that may be driving this, such as authorities that are imbued upon a person that, you know, their word is now spread because they are in that position as opposed to
Right.
it being a factor of there?
Right. There's a more conservative force. I think that's entirely plausible. I mean, I'm just thinking now. I mean, what do we do this on, right? I mean, if you had the history of, you know, religious ritual, in particular with domination, perhaps we have translations of the Bible.
Because
There's commentary on the Torah.
Yeah.
That's a good one, actually, because there's enough data there, because it's been running for a while. Yeah, and that's also a network, which is really fun. You know, like, what's more controversial than criticizing string theory? Probably saying, okay, you know, Judaism is novelty bias. I don't know, right? Like, what's the worst thing you can say? Like, I'm not saying. Yeah, I'd have to go underground. But it's a lovely question. And I mean, one of the things, I mean, so, you know, in the end, one of the ways I thought about this is play. Science is play. We don't, you know, we're not maximizing utility function when we write a poem or write a paper. Somebody who's writing a paper to get more citations is not a good scientist, and we all agree. We often think we know when they're doing it. Play is really fun. Do you guys know Calvin Ball? Right? It's okay. Great. So Calvin Ball is the game. It's in Calvin Hobbes' comic, and it's the game where the only rule is that you can't invoke the same rule twice. Right? So this is the ultimate novelty bias, right? And the problem is Calvin Ball, okay, it's fun for Calvin, but no game would be fun that actually truly was Calvin Ball. And we do need some kind of inertia in the system for us to actually play. And you see that in part because overall, right, novelty and transience, this goes up, this goes up. Thank you very much.